many objects have you interacted with today? I'm talking food, phones, flowers, doors, your keyboard, possibly even a pet, maybe 100 or more things. Well, what if I told you everything you've ever touched, held, felt, or eaten was built from fewer than 100 basic building blocks, assembled together in different ways? These building blocks are called atoms, and they make up all the matter in the entire universe, including you and me. Living in the 21st century, we kind of take the concept of atoms for granted. But since humans can't see atoms, it took us thousands of years to come around to the idea of their existence. In fact, the ancient Greeks thought that everything in the universe was made up of earth, fire, wind, or water. It wasn't until 1880 that Ludwig Boltzmann argued passionately and repeatedly that matter is made up of atoms. And even then, he would frequently lose public debates on them. The existence of atoms and how they behave is not obvious. It's not intuitive, and it's okay if it takes a while to understand these concepts. It took humanity thousands of years to get there, and this course is designed to get you there too. By the time we're done, you'll understand a great deal more about atoms and how they interact with one another. The first thing you need to know about atoms is that they're small, like really, really, really small. In fact, there are more atoms in this toy building block than there are stars in the entire universe, by a considerable margin. We live in the world of feet and meters, pounds and kilograms, what we call the macroscopic scale. But atoms, they exist down at a scale of nanometers and atomic mass units. That's what we call the atomic scale. But we can't even see at this small of a scale. So we have to represent it with illustrations or language. To think about atoms, we need to connect what's happening at the atomic scale up to what's happening at the macroscopic scale, and vice versa. Okay, for example, if we only look at the macroscopic scale, it can have real consequences. Take these two balloons. They're each filled with a clear, colorless gas that allows them to float. Now, to us, at the macroscopic scale, the gases look pretty much the same. But if we excite the atoms that make up these gases by, say, adding a flame, we see that they're completely different. Oh. So what's happening here? Well, if we had examined these gases at the atomic scale, we would have seen right away that they're totally different. The first balloon contained helium, just like the balloons at a birthday party, which is why it just popped. But the second balloon contained hydrogen, which is extremely flammable. That's how we got the big fireball. Thinking about the world at the atomic scale allows us to do more than just make sure our birthday parties are safe. Understanding that atoms make up everything and how those atoms interact with each other is critical to advancing our quality of life on this planet.